So now, so let's see. So we got rid of our console window. So now we can jump to try to inject to our target process. So explorer.exe. We can actually close that. Let's compile it. And so let's run it. And it got executed. And Windows Defender Antivirus found our injection. Really pretty cool. All right. So first, let's see if this payload was actually executed from explorer.exe. Okay. So we go to here, and we see that it was Explorer. Let's find the allocated buffer by our dropper, and it is here, and it's our payload. Okay, so our dropper works as it's supposed to. Okay, but we have a problem with Windows Defender, which detects our malware. And to be honest, that kind of situation is pretty common. So when you develop a malware, you will probably quite often get that kind of behavior from AV, and you actually need that kind of testing. So what we need to do is we need to figure out what how a Windows Defender detected our malware. Okay, so we can check if what kind of information it provides. So let's go to quarantine, see some details, and it says Win32 agent bypass, generic, alert level severe, recommended action quarantine, category Trojan, and this program is dangerous and executes commands from an attack. And a path to our implant. Okay, so not too many information. So what we can do, let's first figure out if it was due to injection, so during the runtime, or it was a static analysis. Okay, so since the program is already gone, it has been quarantined by Windows Defender. So let's compile it again. Okay, and let's just copy this, okay, to somewhere to the C drive and see what happens. And Windows Defender detects that implant. So it means that probably detection is based on static analysis. Okay, so not runtime. AV is not does not see the injection, but based on static analysis, it flags that file as malicious. Okay, so let's go back to our project, and okay, so if you might recall from function call obfuscation chapter, I told you about that kind of technique. It's pretty common in AV industry. So we need to change some our source code and get rid of some static function calls. So we need to change our import address table. And the most common detection is that AV are looking for these combinations of calls. So virtual alloc ex, write process memory, and create remote thread. So let's get rid of them and use the pointer instead of direct calls. So let's start with virtual alloc. So we go to MSDN, paste, We take this function and let's see, it is Windows, it's kernel 32, so it's implemented there. So we scroll up and add this here, paste, and we WinAPI a pointer. Okay, so that's the first function. Now we go with the second one. So let's go back and write process memory. So we copy this and check the, yeah, it's kernel 32. We scroll up, we add it here, and WinAPI pointer. Okay, let's save it. And the last one is create remote thread. So copy. And we go back. Create remote thread. Copy. And it should be kernel 32 as well. Yes. And paste. WinAPI pointer. Okay, we got it. So we have the pointers defined. So we need to resolve them here. So we have virtual alloc. We have write remote process memory, and we have create remote thread. Okay, so we need to get proc address with get module handle to kernel 32.dll, and with the function name. So let's copy these, copy, paste, paste, and we need function names. And so we put strings here, but let's do it in the right way. Since we have XOR function here, let's use encrypted versions of these strings. So let's copy this into here, and it's gonna be string. Okay, copy this here, some string, again copy this here, and it's gonna be string. Okay, so we need these strings here defined. Unsigned car, copy, paste. So the first one, car, second one, unsigned car, copy, paste. Okay, so we have our variables. And now we need to decode them. Okay, so let's take decrypt them, sorry, not decode, decrypt. So we put 3 times, and we need this here, here, we copy, paste, paste, we need copy, paste, paste. And of course the second argument was a size, so the size of this array. Okay. And size of, okay, let's save it. So we have these, we decrypt them, then we resolve the addresses, and then we need to use these calls here. Okay, so pointer, pointer, and pointer. Okay, now, oh, the key, so we need a key. There's a key which is also used in main function. So let's remove that and make it a global variable. So let's move it here, paste. Okay, so now the key is available. So we're gonna be using the same key for both the encrypted characters, encrypted function strings, and for our payload. Of course, you can use different passwords. That's okay, and even a dedicated password per string. That's also fine. So now we need to generate these strings. So let's go to Python, interactive. So it's XOR, our function name, which is this one, copy, and our password, which is here, copy, paste, and we can't use that, so there should be a function called print ciphertext. So we copy this and we just reformat the output. So here's our first encrypted string. So we paste it, then we use the second one, write process memory, and write process memory. Okay, looks good. Copy, paste, and we use this one as well. So copy remote thread, and yeah, looks good. So we copy this, paste it here. Okay, let's reanalyze again. So we have our strings, encrypted strings here. These function names get decrypted here. Then we resolve the addresses, function calls, and then we use these pointers. Okay, and key is here, which is there. Okay, it looks good to me. So let's try to compile it again. Let's exit Python and compile it again. You're missing line 96, so we're missing something. Oh yeah, that's the problem here. Get rid of it again, compile, and let's see what happens. So refresh. and let's launch it. So our payload executed and there was no detection. Let's make sure it is actually, it was started from Explorer. And now let's see if there is another region mapped with the shellcode. There's the second region, this one, and this one. Yeah, it's so yeah, it looks like it worked. So again, as you can see, function call obfuscation, we changed the main function a little bit as well, because we removed the key to become a global variable. It might change something with the logic, since the main function is also changed. So maybe some hash or signature changed. So yeah, this is how you can bypass antivirus. And as I said, it's a common technique, detecting specific function calls. So yeah, that was it.